But let's make another one, the cross topology. Let's assume A and B want to exchange two packets, C and D the same, and the relay has to do something. Now, you will do the same. The outer nodes will send their packets. A will send it out to the relay. Even C and D are not interested, they are just storing it. The same with B, then C and D. Now, the relay could have done already earlier a combination of A and B, but he will wait for more than that, and now you have A, B, C, D, everything here. You combine that and send it out. So get one coded packet to all sides, and the coded packet now will be resolved to one nice one, and now you have a bigger gain. It's not 33 again. And you coded also more packets together, not only two. So this shows we are not limited to only two packets. We could do even more than that. So this is what we had also as an example in the Mythbuster paper for network coding with Muriel. So it's not over that. What is the trick part here? So we always assume that the overhearing went well, right? So the problem is it's very unstable if one of the overhearings does not go through. Okay? Now, there will be a solution for this, but this comes later in the lectures. There's a protocol called CORE, right, which is a combination of COPE and more, and you will hear about this later on. Good. So now in the interflow network coding, there are some very good advantages. It's very low complex. I mean, the examples we had, hey, super. Let's just implement it. There's no delay. The actual coding is quite simple. It's just a simple XOR. It should be easy to integrate it. And later we can use something for analog network coding. Even though you don't know it, it's actually the same idea behind it. Then the other thing is, on the negative side, we need a certain planning and bookkeeping, and we also need certain characteristic of the traffic. So if you have Alice and Bob, and you always want to let them exchange, you assume that they always have something to change. What if one side has more to send than the other? Or what if the other side doesn't even have to send anything, only one direction? Then you cannot code anything, okay? But this is not the end of network coding. Network coding will come with a different tool for that. But for this, where you really look into the flows and you would like to combine them, you are very prone to the characteristics of your traffic. So you will see this later on.